Hello, this is Abhijit Mukherjee. Today we are going to study Class 7, Chapter 4, Part 3, Chemicals and Chemical Changes. We are going to learn how to write balanced chemical equations. In this topic, we are going to revise this part once again. You must know from the beginning the formula of all the chemicals involved in a chemical reaction. For this, the step 1 would be to identify all the reactants that are present in a reaction. For example, if we see this reaction where magnesium bonds in oxygen to form magnesium oxide, this magnesium and the oxygen are the starting point. So these are the reactants and the finishing point is magnesium oxide. So we must differentiate these two things. The magnesium and oxygen has to be written first in the form of reactants followed by magnesium oxide products. So separately these reactants are to be written from the products. Initial participants are called reactants and these are those which are going to start a chemical reaction. So here in this case it will be magnesium Mg and oxygen O2 which are the reactants. So we are going to write MgO, the magnesium oxide, as the product. In the step 2, we are going to write the left side one by one all the reactants and putting a plus sign in between each of the reactants so that we make it on the left hand side all the reactants and it becomes Mg plus O2 on the left hand side. Then we are going to put an arrow directing towards the right after all the reactants. So it will become Mg plus O2 arrow. In the next step, that is the third step, we are going to put the products one by one on the right hand side of the arrow. In this case, there is only one product, so it would become MgO and the reaction would become Mg plus O2 arrow MgO. So this is the chemical equation. But students, this is not balanced chemical equation. So in step 4, we need to balance the chemical equation. And this is how you identify the chemical equation of a particular element at a time and you balance it. So one of the element has to be identified and balanced. For example, in the reactants and the product side, if you observe, the magnesium is on the left hand side, magnesium oxide on the right hand side. In both cases, they represent magnesium. Oxygen on the left hand side and magnesium oxide on the right hand side. In both cases, they have the oxygen. So we need to balance the magnesium in the first step and oxygen in the second step. In step 5, we are going to count the number of atoms of each of these elements on either sides of the arrow. So in this case, the reactants and the products seems as magnesium giving magnesium oxide. So magnesium is on the left hand side only one atom and magnesium oxide has also one atom of magnesium. So in both cases on left hand side and right hand side, magnesium is equal. So we have to repeat this same process with other elements also. For example, on the reactant side it is oxygen O2 which has two atoms of oxygen, and on the product side the oxygen is present in the form MgO where it is one atom of oxygen. So two atoms on the left hand side of oxygen and one atom on the right hand side of oxygen. So in this step 6, we need to make these number of atoms equal on both sides by using the process of multiplication. Now we are going to see how it is done. We use the magnesium giving MgO where it is one Mg atom on the left hand side and one Mg atom in the form of magnesium oxide on the right hand side. So both these cases show same atoms of magnesium which is balanced, and we repeat this for every other element separately. But we are going to see, although it is balanced for magnesium, it is not balanced for oxygen. If you notice, the oxygen on the left hand side has two atoms in the form of oxygen O2 and it is MgO which is having only one atom. So we need to multiply. So left hand side 2 atom has to be multiplied into 1, so we get 2 which will become equals to on the right hand side which is 1 atom oxygen into 2 equals to 2. O2 becomes 2 MgO that thing which we have multiplied is 1 on the left hand side, so it remains 1 O2. On the right hand side we multiplied by 2, so becomes 2 MgO, 2 atoms of oxygen. In step 7 we actually put all these multiples that we have multiplied just before the appropriate places of the formulas. Balanced equation would be 2Mg plus O2 arrow 2MgO, which is the final balanced chemical equation. So this is how we do all the balancing, and the equation must be balanced to complete it. Next, we are going to write the formula of another chemical equation and balance it. Let us find writing and balancing the equation aluminium plus chlorine giving aluminium chloride. Now in this case, we know the formula of aluminium as Al, chlorine as Cl2. Let us find out aluminum chloride. So writing the element Al and Cl separately, writing the valencies of aluminium below aluminium and valency of chlorine as 1. So these 3 and 1 gets exchanged and the ultimate formula becomes Al1Cl3. We write AlCl3. This is a formula of AlCl3. So on the reactant side it becomes aluminium plus Cl2 giving AlCl3. So reactants arrow products. This is the formula equation. Now we have to balance it. Now if we see the reactants on the left hand side, aluminium is 1 atom of aluminium, which is in the form of AlCl3, which is also 1 atom of aluminium. So it is already balanced. Aluminium need not be balanced. But we see in the case of the chlorine, on the reactant side it is Cl2, which is getting converted into AlCl3. In each of them there is Cl, so we have to identify them. We see 2 chlorine atoms in Cl2 and 3 chlorine atoms in AlCl3. So they are not balanced. We need to balance them. So to balance the 2 atoms of chlorine on the left hand side with the 3 atoms of chlorine on the right hand side, you need to multiply on the left hand side by 3 and the right hand side by 2. So we get 6 atoms of chlorine on the left hand side and 6 atoms of chlorine on the right hand side. So the Cl2 takes a 3 in the front because we have multiplied with 3, and the AlCl3 takes a 2 in front because we have multiplied by 2. So this is how we balance the chlorine atoms. Next, the final balanced equation is now adjusting all the multiples. So before Al it becomes 2 and before Cl2 it becomes 3. So it is 2Al plus 3Cl2 giving 2 AlCl3. That's the final balanced equation. Now we are going to see another equation of balancing H2 plus O2 giving H2O. In this case we separate the atoms of hydrogen. So in the left hand side is H2, which is having 2 hydrogen atoms, and the right hand side it is H2, it is also 2 hydrogen atoms, so it is already balanced. But in the case of oxygen we see O2, 2 atoms of oxygen on the left hand side, and H2 has only 1 atom of oxygen, and the right hand side oxygen with 2, so it becomes 2 also. So both these cases we have 2 oxygen atoms. So O2 now is multiplied by 2 in the right hand side of the H2O, so the equation becomes O2 with 2H2O. So if we get this, now we find out H2 we have already seen as balanced with hydrogen H2O, and the oxygen is balanced at 2H2, so it becomes 2H2O. The final balanced equation will be 2H2 plus O2 giving 2H2O, because in this case both hydrogen and oxygen has to be balanced on both sides. Another equation we are going to balance is N2 plus H2 giving NH3. Here we are separating the nitrogen and the hydrogen. So on the left hand side we first going to balance the nitrogen. So N2 giving NH3. Left hand side we have 2 nitrogen atoms from N2 and NH3 has 1 nitrogen atom. So we need to balance these 2 nitrogen atom and 1 nitrogen atom on either sides. So we multiply 2 with side, 1 with left hand side and 2 with the right hand side. So we get 2 of nitrogen on both sides. In the case of balancing our hydrogen with NH3, we get 2 hydrogen atoms on the left hand side, 3 hydrogen atoms on the right hand side. So we multiply 3 on the left hand side and 2 on the right hand side, getting 6 hydrogen atoms on either sides. So it becomes 3 of H2 because we have multiplied with 3 on the left hand side, and 2 of NH3 because we have multiplied with 2 on the right hand side. So the final balanced equation will be showing this N2 plus 3H2 with 2 NH3. Let us find out the final balanced equation, which will show as N2 plus 3H2 giving 2 NH3. So this is how we balance equation. Let's see another equation. It is balancing the KClO3, which is giving KCl plus O2. So we are separating the potassium, the chlorine and the oxygen. In the first equation we are balancing the oxygen. So if you see 2 KClO3 giving 3 O2, means 6 of oxygen on the left hand side, 6 of oxygen on the right hand side. Next we balance the chlorine. 2 KClO3 means 2 Cl is there on the left hand side. The right hand side 2 KCl has 2 chlorine atoms. So K, Cl and O are already it is balanced like 2 KClO3 giving 2 KCl plus 3O2 is the final balanced equation. And in this balancing of equation, we are balancing Cl in the case of HCl plus MgOH whole twice giving MgCl2 plus H2O. So what we are doing is we are putting 2 before the HCl so that we balance it with 2 chlorine atom of MgCl2. And in the next step, it becomes 2HCl giving plus 2 MgOH giving MgCl2 plus 2H2O. In the next step, we are balancing hydrogen, putting the 2 of water, and therefore we get 4 of hydrogen there. Thus the equation is balanced finally. 2HCl plus MgOH whole twice giving MgCl2 plus 2H2O. Next equation, we are going to balance K plus H2 giving KOH plus H2. To see that balancing is K and oxygen is already balanced in this equation. So what we have to balance is only hydrogen. So we see it in observe. If we put 2 before H2O, it becomes 2 before KOH and 2 before K. It is a final balanced equation. 2K plus 2H2O giving 2KOH plus H2. That's all for today. Thank you very much. I hope you have understood the balancing of equations. Thank you. Bye. Best of luck. See you again.